YouTube channel. In this video, we are going to see various methods of machine learning. So, methods of machine learning. It's a very important topic, and to understand the various techniques that are used by machine learning, it is very important that we first discuss the methods of machine learning, and then we discuss about various techniques which actually involves writing algorithms and respective things. So mainly there are two broad methods of machine learning. One is supervised machine learning, and the second one is unsupervised machine learning. Yeah. So I will first understand supervised machine learning method. In the supervised machine learning method, what happens is basically this particular method uses labeled data, yeah, to train the particular model. Now basically, if you see this particular thing, then I have just considered a very simple example just to convey the concept that let's say we have different shapes, right? Now being you and me are human beings, and we just by seeing the shape, we know in our brain that this is a circle, this is a square, and this is a line. But the model or the machine learning algorithm will not know it unless and until you train it that way, right? So say this is your model, so you have to explicitly tell this particular model that this kind of shape is known as circle, this kind of shape is known as square, and this kind of shape is a line, right? So this is known as labeled data. Basically, whatever category of data is present in front of you at this point in time is known as labeled data. And this method of machine learning, which is supervised machine learning, it uses labeled data to train the model, right? So here, like, longer the data set that you use to train the model, clever and accurate your model will be. Now if you just apply these three shape as your training data set to your model, then your model will just understand these three shapes. And let's say as a let's say you started using this particular model in production system, and for example hexagon came as an input to this model, then definitely this model won't be able to predict that what kind of or what is the name of that particular shape, right? So to understand this is a supervised learning, and it uses this labeled data, right? Whatever you are seeing here is known as labeled data. So these are the labels, right? And it uses this particular data. Now let's say we have these labels, we trained our model to understand these two labels. So what will happen, let's say we deployed this particular model in production, and in production say it got this particular input. So certainly this particular model understand that this kind of shape is a circle. So at the time of prediction, as a result of this particular system, it will say this is a circle because it knows, right? Now let's say if it is a square, that's fine, but let's take something different. Let's say it got triangle as a at the time of production, let's say it got triangle, but it doesn't know it is a triangle, right? So in that case, what will happen, it will not be able to produce this particular basically it will not be able to tell that this is a triangle, and this is where the model will give you some kind of, I'll not say it will give you error, but it might give you something such as undefined or something like that, right? Because model doesn't know this particular shape. So this is kind of a, a visual that you can use, in which you can understand supervised learning. And here basically lots of human involvement is required, right? Because these are the labels that you are currently seeing, right? These are something that are being, given by humans to, to train the particular model, right? So lots of human involvement is needed. It uses labels to train the particular model, though it is very easy to use, and the accuracy of this particular learning method is very very high, right? Because it like, as you can see here itself, right? The way the model is being trained decides the accuracy of a supervised learning algorithm or method, right? So it is easy and it is accurate. Now basically, which are the techniques in which this supervised learning gets used? There are two types of techniques of machine learning, called as, one is regression testing, technique, and another one is classification technique. In both of these techniques, the method that is being used is supervised learning. Now, what are some, I'll not say drawbacks, but what are, basically what slows down this particular learning method is, see, even though this particular method is accurate, to train the machine learning model, big volumes of label data is needed. Now, this is what we also discussed earlier, that the longer you use your data, use various shapes, like for example a line can be a pointed line, or a parallel line, sorry, a vertical line, or it could be a horizontal line, it could be a dotted line. So this is like a more accurate input that you can use. So more the accurate input, or more the accurate labels that you use to train your model, the prediction will be, highly accurate, right? So this is like directly proportional to what kind of testing data set that's been used to train the model, right? And that's the reason it is a time intensive process, right? It takes time. Like for example, in this particular case, right, we have this triangle which was a new input to the model, and then model could not predict that. Then again humans will come into the picture. They'll retrain this particular model by adding the triangle shape, then again deploy that model into the production, and from that particular point onwards your model will be able to predict that yes, it is a triangle, right? That's the reason it is a time intensive process, and it is expensive as well, right? Because human needs to take a responsibility of the outcomes or completeness of the data. There is one more concept called as how, like, what is the completeness of your data. Now here, if you can say, like, if you have covered all the shapes that are available, then you can say you have the completeness of data. But as you can see here, this just for example, we have just considered three shapes. There are lots of shapes that are available, right? But we have not considered that. So it is the ownership of, let's say, me. Let's say I'm designing this particular machine. So it will be the responsibility of me to train this particular model with all the available set of labels regarding the scope of this. Like this model, what does this model does is it predicts the shape. So within the shape, like n number of shapes that are available, there is my responsibility to apply these all those particular shapes as a training to this particular model, and then I can expect this model to be accurate, right? So ownership is still with the humans, right? If your inputs are biased, then obviously your outcomes will also be affected, right? It will basically give you undefined or maybe the wrong predictions as well. So it all depends on what kind of labels that you have used to train the model, basically, right? So this is about the supervised learning, guys. I hope you must have understood this particular concept, and basically the terms related to this. right? In the next video, I'll just stop it here, because if we started explaining the unsupervised learning, which is the next part of machine learning method, then it will unnecessarily become a you know big video. So instead of that, I'll just stop it here, and I'll see you in the next video for unsupervised learning. Thanks for watching this, and I'll see you in the next one.